Scientific approach to knowledge. We approach gaining knowledge in science in a specific way. It's empirical, it's based on observation and experiment. And this is known as the scientific method. It's a process. It's not a rigid set of rules. It's just a process, an overall approach to observing nature, making observations and conclusions. So the key characteristics of the scientific method, and I'm going to be going over this fairly quickly, include observation, the formulation of hypotheses, experimentation, and formulation of laws and theories. So observations are also known as data. These are things that we can observe, sometimes with our five senses, sometimes we need an instrument to observe these things, but they're things that can be observed. As an example, Antoine Lavoisier, back in the 1700s, was fascinated, as many people are, by things that burn, right? And so he did something a little different. He burned stuff in a closed container and weighed the container before and after. And what he found was that if you burn something in a closed container, the mass of it doesn't change. Now, if you put a log in the fireplace, it's really heavy. You stick it in there, you light a fire if the air board allows you to that day, and you have a nice fire, and then when you're done, what's left? Ashes. Do the ashes weigh the same as the log did? No, much, much less, right? What happened to the mass that was in that piece of wood? That's the sort of thing that Lavoisier was interested in. So he tried burning stuff in a closed container, and he found that the mass did not change. So this was an important observation. The observation can lead to a hypothesis. A hypothesis is a tentative interpretation or an explanation of these observations. So he observes that this happens, the mass doesn't change, and he's trying to propose an explanation. So he said, well, when the substance burns, it must combine with something that's in the air. And that was his hypothesis. A critical component or characteristic of a hypothesis is that it could be falsified, meaning it can be tested and possibly proven incorrect. If the hypothesis cannot be tested, then it's no good. So then we take that hypothesis and we test it using experiments. In the experiment, we try to control all of the variables so that we get observations from that experiment that help us to either support the hypothesis, yeah, that might be true, or to prove it wrong. If the hypothesis is proved wrong, we have two options. We can throw it out entirely, or we can modify it and then test the modified hypothesis. Hypotheses can lead to laws and theories. It's important to understand the difference between these two. So a scientific law is just a brief statement that summarizes past observations, and it can predict future ones. It doesn't say why this happens, it just says what happens. The law of gravity is an example. It doesn't explain why things fall, but it says that they will, and we know that that's true. So the law of conservation of mass is the law that came from Lavoisier's experiments. In a chemical reaction, matter is neither created nor destroyed. That's going to be an important principle that we'll talk more about later. Scientific laws are also subject to experimentation, and they may be proven wrong at a later date. Some things that we thought were true, as technology and general scientific knowledge advanced, we have discovered are not true. Unlike the state or federal laws that you can just choose to disregard, you cannot choose to violate a scientific law. You can't decide that you're not going to obey the law of gravity today, and you're going to walk off the top of the 3-story building and just keep going. It doesn't happen. Scientific laws describe how nature behaves. A theory can also come from hypotheses. The theory explains. It's a model for how nature behaves and explains why and how, not just saying this is what happens. So a theory to explain gravity is Well, we're still working on that. We don't fully understand what gravity is yet. But back to Lavoisier's burning things in closed containers. John Dalton, a little bit later, developed a theory to explain the law of conservation of mass. It's called the atomic theory. It says that matter is composed of small indestructible particles called atoms, and since those particles are just rearranged in chemical changes, then the total mass must remain constant. So this takes the law that says what happens and explains why. So laws say what happens, theories say why. Theories are also tested. Something that's a little disturbing is that we can never prove anything to be true. Does that bother you? We can't prove something to be true. We can only prove things to be wrong, or we can say, well, no one's been able to prove this wrong yet, so we will accept it as truth. Where am I going with this? Theories can also be used to predict future behavior, and a well-established theory is as close to truth as we get. So in our everyday lives, we'll say, oh, well, that's just a theory, right? You know, that's somebody just thinking off the top of their head. Probably not true. In science, a theory is a big deal, okay? That's as close to truth as you can get. So this diagram illustrates the scientific method, which is got a lot of loops in it. So you may start with observations and then develop a hypothesis. The hypothesis needs to be tested through experiment, either confirmed or revised, and you can end up in this loop for your entire career, years and years and years. The experiments can lead to laws, which also need to be tested and confirmed. Hypotheses can lead to theories. Again, testing, confirming. Scientists are very skeptical, and if someone else does some experiments and says, here's my theory, we'll say, let me see for myself. And so other people, other scientists will study the same thing and make sure that those results can be replicated. So one thing I want you to be able to do is to identify a statement as being either a theory or a law. So a question like this, which statement best explains the difference between a law and a theory? A law is truth, whereas a theory is a mere speculation. A law summarizes a series of related observations. A theory gives the underlying reasons for them. A theory describes what nature does. A law describes why nature does it. Now, those all sound pretty fancy, right, and scientific. What's the correct answer? B. So letter C has it exactly backwards, right? Theory describes why, and law describes what. And there is no truth in science, and theories are not mere speculations. So the answer is B.